Hello students, welcome back to my channel. Today we will study the topics of group theory which would be useful in TIFR exam. That is, we will study some questions related to CELO theory and some of its results. Now let's get started. Some results which are number 1. If order of G is equal to P square Q, then there exists at least one normal silo subgroup and therefore G is not simple. Second, if order of G is equal to P square Q square, again G is not simple. Third, Silo's test for simplicity states that for n belong to positive integer such that n is not prime and P divides n, if 1 is the only divisor of n congruent to 1 modulo p, then there does not exist simple group of order n. Now, fourth, odd test integer of the form 2n where n is odd and n is greater than 1 is not the order of a simple group. Basically, it is not a simple group. Fifth, index theorem. G be finite group and H be a proper subgroup such that order of G does not divide the index of H and G cofactorial, then H contains a non-trivial normal subgroup of G, which in turn implies G is not simple. Sixth result which we have is G be finite non-abelian simple group and H be a subgroup of G, then index of H in G is greater than or equal to 5. Seventh result which we have is G be finite group such that for P divides order of G, where P is the smallest divisor, prime divisor, then subgroup of H of index P in G is normal in G. Implies H is normal in G. Another result which we will do is if order of G is PQR, where PQR and distinct primes such that P is less than Q less than R, implies G is not simple. I already told you that R silo subgroup is unique here in my previous lecture. Now we will do proof of this. Suppose no silo subgroup of G is normal. Number of silo P subgroups NP is equal to 1 plus Kp divides Qr, that is NP is equal to, cannot be 1 because no silo P subgroup of G is normal, hence no silo subgroup of G is unique. Therefore it would be QR or QR. Number of silo Q subgroups in G is which divides PR implies NQ is equal to PR or PR. It cannot be equal to P since Q cannot divide P minus 1 as Q is greater than P. Therefore, we have two choices. Now, number of silo subgroup R subgroups divides PQ, that is NR is equal to PQ or PQ. In the case when it is PRQ, it implies that R divides P minus 1 and here it divides R divides Q minus 1, which implies R is less than P, R is less than Q, which is a contradiction. Hence, the only choice left for N number of silo R subgroups of G is PQ. Now, it implies silo P subgroups of G हमें कितने एलिमेंट्स देंगे of order P? Phi of P of order P, and at least we have Q silo subgroups because R is greater than Q and QR is obviously greater than Q and R. Hence we have at least Q into phi P elements of order P. Similarly, silo Q subgroups of G give at least R into phi of Q elements of order Q and silo R subgroup of G give not at least PQ into phi of R elements of order R. PQ because we have PQ R subgroups in G. Hence order of G would be, that is PQR would be greater than or equal to Q into phi of P, that is P minus 1 since P is prime, plus R into Q minus 1 since Q is also prime, plus PQ into R minus 1, that is PQR plus PQ minus Q plus RQ minus R minus PQ, that is PQR minus Q minus R plus RQ plus 1 also we will add for identity element. Now, which in turn implies that RQ minus Q minus R plus 1 is less than or equal to 0. Since factorizing it would imply that Q minus 1 and R minus 1 is less than 0, which is clearly a contradiction because neither Q minus 1 nor R minus 1 is less than 0. Hence their product cannot be less than 0 because P, Q, R were distinct primes such that P is the smallest prime. So at least Q and R would be greater than or equal to 5. We arrive at a contradiction which says that some Sylow subgroup of G is normal and hence G is not simple.